Okay, so we are doing second order differential equation, right? The meaning of order means you differentiate y 2 times. Second order means differentiate y 2 times, all right? So that's how second order come from. Differentiate y 2 times. Now another thing in differential equation is about degree. Okay, what is the degree here? This, for example, if we have equation d2y dx squared, let's say 3 plus dy dx 4, for example, equal to sine x, for example. This is a differential equation. So what is the degree now? Degree is highest power, okay? So in this case, higher power degree. Compare them, all right? So this is called degree of differential equation. Of course, these are the sum of terms we have come across. Okay. Now, if you look at the differential equation, usually the left-hand side called y. What you're trying to find out is y here. Then the right-hand side is a function of x here. So if a function of x, this one is equal to 0, for example, if this is equal to 0, then we call this homogeneous. Okay, homogeneous basically say that the equation is easier to solve because one side equals 0. Okay, and if the right hand side is not equal to 0, then we say that this is non-homogeneous. Okay, then in particular we are looking at what happens if a0, a1, a2 are just constant. Okay, so suppose a0, a1, a2 are just constant. That means that say instead of x here, a0x, a1x, a2x, suppose they are just number. Okay, so these are let's say that this is a with constant coefficient, and we focus on constant coefficient, and especially a0 not 0, right? If a0 is 0, it's just like first order differential equation. Okay, so this is the first slide, an introduction, telling you what is the order, second order. If you have first order, means the differentiate y only one time. Okay, then let's start with a simple one. How to find the solution of a differential equation with constant coefficient, and the right hand side is equal to 0. Right hand side equal to 0, we know that this is what we call a homogeneous equation. Okay, for second order, this is called homogeneous equation. The right hand side equal to 0. So now, how do you know the solution of this second order differential equation look like? Okay, so usually the second order differential equation, you need two solutions. Okay, they are called linearly independent solution. Okay, you need two solutions. One of them is called y1, one of them is called y2. So there are two linearly differential independent differential solution, y1 and y2. Both of them are function of x here. They are linearly independent. Then if you find these two solutions, then any combination, every solution is a combination of y1 and y2. So it looks like this. So all the possible solutions, then once you get two linearly independent solutions already, you can find that the y generally look like this, combination of y1 and y2. Okay, so combination of y1 and y2. So how do you know that this is a solution? Now, if you have if this is one of the solution, if you have y1 and y2 already, then any combination of y1 and y2 is also general solution. So all the general solution will look something like this. So for example, if you have y1, let's say, for example, I give you a proof here, simple one. For example, if y1 the solution means you put y1 inside there, So a d2y1 over dx1 dx squared plus b dy1 dx plus c y1 give you 0. Okay, and also for y2, suppose y2 is another solution. dy2 dx squared plus b dy2 dx plus cy2 equals 0. Okay, so now I want to show you that if you have y is equal to c1 combination of y1 and c2 of another combination of y2, right? How do you show that this is a solution? Solution means what? You put inside the differential equation, you should get 0. All right, so you put it, substitute into this star here, substitute into star here, okay, this equation. Then you get, say, a d2 y is actually c1 y1, right? So this is actually dx squared c1 y1 plus c2 y2, okay, plus b dx c1 y1 plus c2 y2 plus c. Okay, I need to shift this a little bit, otherwise no space, all right? So I'm going to shift it a little bit here. So shift this a little bit here. Okay, plus c times c1 y1 plus c2 y2. Okay, I want to show that this is equal to 0. So what you can do, okay, actually you can, because you know differentiation 2 times is actually, the first one is actually c1, then you differentiate a, okay, I differentiate d2y1, okay, dx squared okay, then the next one is actually c2 d2, that's a also, yeah. So I think I want to put a somewhere also, same, put a here. The a d2y2 dx squared. So this is what I get for the first term. Then b c1 dy1 dx plus b c2 dy2 dx, right? So let me put it across. Okay, so you see now, let's see, I put them together. I need another c, right? So actually c c1 y c1 y1, okay, c1 y1 plus c2 y2, and there's a c there. So I multiply everything by c, huh? So well, they give you 0. So what you can do, organize a term. So organize a term. So I want to put this one, all the y1 together. Okay, so you put them all together, you'll find that all the y1 put together, right? So let me right over here, the left hand side here, all the y1 put together. So I have actually c1 a dy1 dx square, okay, first term. Okay, I will use a yellow color one, and then plus b dy1 dx, okay, or the yellow one, bc1, bc1, take out, right, c1b, and then the last term is c y1, okay, and where you can put that the c1 is common term, right, all the c1 are common term for first term, and then plus c2 now. So c2 now is actually this term, this term, this term, right? So we add them up. This is actually a d2y2 dx square plus b dy2 dx plus c y2. Okay, y is equal to 0 now because y1, because of this term, okay, because of this term here. So this thing is equal to 0. Okay, and then of course because of here, and then because of this one, this also equals 0. So you end up any combination of y1 and y2, you put them together, is also a solution for this homogeneous equation. So all the solution of this type of equation is actually a combination of two solutions, y1 and y2. Okay, so then the question is how to find your y1 and y2. Okay, so let's stop the recording for a while first, because I want to talk about something else here. So stop recording now. So